Hi guys, it's me again, Angelica Patulot. Welcome to another video. So for today's video, I'm going to discuss you the summary of chapter 9, which is entitled Transport Layer. So before we begin this chapter, we need to open first the NetAcad. So for chapter 9, the topics under chapter 9 are transport layer. Under 9.1, transport layer protocols. Under it is transportation of data. Under transportation of data, we have role of the transport layer responsibilities, conversation multiplexing, transport layer reliability, TCP, UDP, and the right transport layer protocol for the right application. Then TCP and UDP overview. We have TCP features, TCP header, UDP features, UDP header, multiple separate conversations, port numbers, socket pairs, port number groups, the netstat command. Then under TCP and UDP, we have TCP communication process. Under this, we have TCP server processes, connection establishment, TCP session termination, three-way handshake analysis. Then we have here the insert activities. Then for reliability and flow control, we have TCP reliability order delivery, TCP flow control, window size and acknowledgements, TCP flow control, congestion avoidance. Then UDP communication, we have low overhead versus reliability, datagram reassembly, server processes and requests, client processes. Then under TCP and UDP, under it we have applications that used TCP, applications that use UDP. Then here are the activities. Then for the summary, we have 3 activities. The class activity we need to talk again, it's a game. Then 9.3.1.2 packet tracer, TCP and UDP communications, and 9.3.1.3 transport layer. So for the introduction of this chapter, we will open the class, return to class. So data networks and the internet support the human network by supplying reliable communication between people. On a single device, people can use multiple applications and services, such as email, the web, and instant messaging, to send messages or retrieve information. Data from each of these applications is packaged, transported, and delivered to the appropriate application on the destination device. The processes described in the OSI transport layer accept data from the application layer and prepare it for addressing at the network layer. A source computer communicates with a receiving computer to decide how to break up data into segments, how to make sure none of the segments get lost, and how to verify all the segments arrived. When thinking about the transport layer, think of a shipping department preparing a single order of multiple packages for delivery. So, let's proceed to my PowerPoint presentation for the summary of Chapter 9 Transport Layer. So, here is my PowerPoint. So, Chapter 9 began with an overview of the purpose of Cisco iOS access lists and their role in filtering network traffic. This included a look at the order in which access lists are evaluated, the different types of access lists that exist, such as standard and extended, as well as the different ways in which access lists are applied to router interfaces, inbound, such as inbound and outbound. So the implicit deny all statement at the end of every access list was also discussed. Then, a look at standard IP access lists outlined their ability to filter traffic based on the source IP address of a packet. The access list command was introduced for the purpose of adding entries to an access list, as, as was the access group command, which is used to standard and extended access list to an interface. A look at wildcard masking explained how groups of computers could be specified within an access list. An overview of extended IP access lists provide perspective on the more granular level of filtering control that these access lists provide by source and destination IP address, as well as by protocol and port number. The ability to monitor IP access lists was examined by looking at the command used to view access lists defined on the router, as well as those applied to interfaces. IPX standard and extended access lists were looked at next. Standard IPX access lists can filter traffic by source or destination address. Extended IPX lists provide a finer level of control, allowing traffic to be filtered by protocol and socket number if necessary. An overview of IPX SAP access list showed how SAP traffic could be filtered on a router according to a source address, service type code, and even a server name. Which means the difference between the input SAP filter and output SAP filter commands used to apply SAP access list to interfaces was also discussed. So, for the role of the transport layer is responsible for establishing a temporary communication session between to applications and delivering data between them. Transport layer responsibilities: tracking individual conversations by tracking each individual conversation flowing between a source application and a destination application separately. Segmenting data and reassembling segments by dividing the data into segments that are easier to manage and transport. Identifying the applications by ensuring, even when multiple applications are running on a device, all applications receive the correct data. Conversation multiplexing: segmenting the data into smaller chunks enables many different communications from many different users to be interleaved, or the multiplexed on the same network. The transport layer adds a header containing binary data organized into several fields. It is the values in these fields that enable various transport layer protocols to perform different functions in managing data communication. For transport layer reliability, transport layer is also responsible for managing reliability requirements. Some applications may not require reliability, but transport layer requirements vary from application to application. TCP or IP provides two transport layer protocols: Transmission Control Protocol or the TCP, and the User Datagram Protocol or the UDP. IP uses these transport protocols to enable hosts to communicate and transfer data. TCP is considered a reliable, full-featured transport layer protocol which allows for packet data delivery confirmation. In contrast, UDP is a simpler transport layer protocol that does not provide for reliability. So this is the end of my presentation for chapter 9. I hope you learned something. Thank you for watching and see you on my next video. Bye!